Hello, good morning everyone. Welcome to Guru Brahma classes for JE and NEET. We are in the chapter Ionic Equilibrium. In this session, we are going to discuss about Bronsted-Lowry theory for acids and bases. Let's start it. So, what theory? We are going to discuss Bronsted-Lowry theory, right? Bronsted-Lowry theory of acids and bases. So, according to Bronsted-Lowry theory, what is acid? A substance which can donate proton is known as acid. So, what is acid according to Bronsted-Lowry theory? Proton donor. Proton is nothing but H plus. So, it should be able to donate proton. It should be able to donate proton. If it has to donate proton, it should have proton. It should have proton. Okay. So without having proton, it cannot donate it, right? So to donate proton, it must have proton, and if it donates that proton, then that is called as acid according to Bronsted-Lowry theory. Okay. Next, a substance which can accept a proton. So what is base according to Bronsted-Lowry theory? Proton. Proton acceptor. Proton acceptor is called as Bronsted-Lowry base. Okay. Next, what is meant by neutralization or protolysis? The transfer of proton from an acid to base is known as neutralization. Okay. Acid is able to donate proton, base is able to take the proton, accept the proton. So the transfer, see, when acid and base are reacting with each other, what does that mean? That means that acid is donating proton, base is accepting proton. The transfer of proton from acid to base is called as neutralization according to Bronsted-Lowry theory, right? So here, according to this theory, acid-base reactions are considered to be reversible. These are reversible. You are finding reversible reaction, right? Now, in the forward reaction, So let us see forward reaction. So this HCl dissolving in water or HCl reacting with water to give you H3O plus and Cl minus. See, HCl, what happened to HCl? It has become Cl minus. So HCl has donated a proton. HCl has donated proton to H2O and became Cl minus. So according to this theory, HCl can be considered as acid. Why it is considered as acid? Because it has donated a proton. H2O, by taking the proton given by HCl, it has converted into H3O plus. See, HCl gave a proton to H2O, so that HCl is converted into Cl minus, H2O is converted into H3O plus, right? So as this HCl gave the proton, it is acid. As H2O accepted a proton, this is a base. We know that H plus plus H2O gives rise to water, H3O plus, right? That is what has happened. This H plus, this is taken by H2O and converted into H3O plus. Understood? So then what will be H2O? H2O took a proton, accepted a proton from HCl, so it is called as a base in the forward direction. The backward direction, let us take. What is that? Backward direction reaction. Okay. Backward. So what you can write? Backward reaction. In this backward reaction, what is this backward reaction? H3O plus reacting with Cl minus gives you HCl and H2O plus. Okay. H3O plus reacting with Cl minus giving you HCl plus H2O. What is this called as a backward reaction? Backward reaction. In this backward reaction, H3O plus is converted into what? H3O plus is converted into H2O. That means it has given one H plus to Cl minus. H3O plus is converted into what? H2O. That means it has lost one H plus. To whom it gave to whom H plus is given to Cl minus. It is given to Cl minus, so that Cl minus is converted into HCl. That means in backward direction, H3O plus is acting as acid, and Cl minus, as it is accepting proton, it is base. So we are seeing two acids and two bases. When considered forward direction reaction or forward reaction, HCl is acid, H2O is base. When you consider backward reaction, H3O plus is acid and Cl minus is base. Cl minus is accepting proton from H3O plus. So there are two acids you are finding. What are those? HCl and H3O plus. That is what here you see. HCl and H3O plus are Bronsted-Lowry acids from this given reaction. And two bases you are finding, H2O and Cl minus. So H2O and Cl minus are Bronsted-Lowry bases. Understood? Right? Again, acid means proton donor, base means proton acceptor. One proton, that's it. Right? In this, if you see HCl and Cl minus, HCl is acid, we are seeing there, and Cl minus is base. What is the difference between these two? The difference between these two is this proton. What is this? A proton. So acid base pair, one acid, one base, a pair of substances, a pair of species, a pair of a species. So one is acid, another is what? Base. So these acid base are differing by a single proton. Such a pair of acid and base is called as conjugate acid base pair. So what we say? Acid base pair that differ by a single proton, and that is called as what? Conjugate acid base pair. Acid base pair. Understood? So what is meant by conjugate acid base pair? The acid base pair that differ by a proton is called as acid base pair. Conjugate acid base pair. See HCl, from this equation HCl and Cl minus are differing by a proton. Another example let us take. Another example is here you are also finding H3O plus. So H3O plus and H2O. What are these two? What are these two? They are differing by a proton. So I can write them as what? Conjugate acid base pair. H3O plus and H2O are conjugate acid base pair. Why? Because one is acid. Who is acid here? Who is acid? H3O plus is acid. Who is base here? H2O is base. Now this acid base pair are differing by a proton. What is the difference between these two? One H plus. What's the difference between H3O plus and H2O? One H plus. So as they are differing by one proton, they are called as what? Conjugate acid base pair. Let us see another reaction here. NH3 is reacting with H2O NH4 plus. So what has happened in forward reaction? Forward reaction, what happened? NH3 took one H plus and converted into NH4 plus. Now it has taken H plus, so it is a base because it has accepted one proton. In the forward reaction, let us see H2O is converted into OH minus plus H plus because it has donated a proton. This proton is donated to NH3. So what is this called as? Acid. So now I can write it as base because it has taken one proton given by water. And what is water? Water donated a proton, so it will be acid in the forward reaction. So let us consider backward reaction. What is that? Backward reaction. So in the backward reaction, if you look into NH4 plus is converted into NH3 by releasing one proton. So as it is donating a proton, it is losing a proton. Now this can be considered to be acid. OH minus took this proton given by NH4 plus and converted into H2O. So in the backward reaction, OH minus is accepting proton. What it is doing? It is accepting proton. As it is accepting proton, I can take it as a base. So now NH4 plus in the backward reaction, NH4 plus is acid and OH minus is base. Okay. So what are acids here? H2O is acid and NH4 plus is acid. See, H2O and NH4 plus are Bronsted-Lowry acids in this reaction according to that reaction. Whereas which are bases? NH3 is base and OH minus is base. So NH3 and OH minus are Bronsted-Lowry bases. And in the given reaction, in this reaction, we know that NH3 and NH4 plus are differing by a proton. What is the difference between these two, NH3 and NH4 plus? See, this one, H plus is the difference. So I can write them as what? Conjugate acid base pair. Conjugate acid base pair. And not only that, if you see here H2O and OH minus, how do they differ? They also differ by a proton. See here, they differ by a proton, this proton. OH minus and H2O. What is the difference between these two? The difference between these two is this proton. Again, I can write, I can consider them as a conjugate acid base pair. Conjugate acid base pair. Understood? So, what is conjugate acid base pair? The acid base pair that differ by a proton, single proton, is called as a conjugate acid base pair. Right? Let us see the next part. So the removal of a proton from Bronsted-Lowry acid gives its conjugate base. Okay. So the conjugate base of HCl is Cl minus. Okay. When one substance is given, okay, let us take HCl. What is its conjugate base? Now only we have studied that conjugate acid base pair means the acid base pair that differ by a proton. So whenever one substance is given, and if it is asked what is the conjugate base of that particular substance, then what you have to do? You have to remove one H plus and write them. So here removal of H plus, removal of proton. If you remove proton from this, what do you get? Cl minus. So Cl minus is the conjugate base of HCl. Simple thing. On removing a proton from a substance, what do we get? Conjugate base. Conjugate base. When is this applicable? This is applicable only when that substance contains proton. If it does not contain proton, and if that proton is non-removable, it is not possible to remove. The condition is that the proton must be present, and that proton must be able to be removed. Removable means here ionizable. Ionizable proton. In some substances, there will be proton, but that proton cannot be ionized, that cannot be removed, that cannot come out as H plus. When it come out as H plus, we can say that it is ionizable proton. Ionizable proton. Right? So, to remove proton from a substance, that substance should contain proton, and that proton must be ionizable proton. It should be able to be removed. Some substances contain proton which cannot be ionizable. That point is important. So if you want to know the conjugate base of a particular substance, then if you remove proton, the remaining species is called as what? A conjugate base. Okay. Now let us see. The conjugate base of H2SO4 is HSO4 minus. Here, if you see H2SO4, this is the structure of H2SO4. Hydrogens attached to oxygen are, oxygen being more electronegative element. If hydrogens are attached to oxygen, simply we have to remember that those hydrogens are ionizable. In which type of acids is these oxy acids? What is that? In oxy acids, hydrogens attached to the more electronegative element oxygen are ionizable hydrogens. These are what? Ionizable hydrogens. That means it can be ionized as H plus. It can be removed as H plus. Now, remove one H plus. If you remove one H plus, then what do you get? O minus OH. H plus is removed. Now what is this? As you have removed one proton, this species is called as what? Conjugate base. Conjugate base of H2SO4. HSO4 minus is called as conjugate base of H2SO4 because removing a proton from H2SO4, what do you get? HSO4 minus. Are you getting this? Right? Conjugate base of whom? H2SO4. Now let us see. What is the conjugate base of H3O plus? Simply what we understood, remove H plus, remove proton. So from H3O plus, if you remove proton, it convert into H2O and H plus. You have removed this proton. Then what is this called as? Conjugate base of whom? H3O plus. Of whom? H3O plus. So H2O is the conjugate base of H3O plus because from H3O plus on removal of H plus proton you got H2O. Understood? In the same way, H2PO4 minus P double bond O minus OH, OH. So what is this? H2PO4 minus. Already I mentioned you that the hydrogens bonded to more electronegative atom, oxygen, those can be replaced or removed or ionizable. They can be ionizable. Understood? So now you say this can be converted into, as this is ionizable, we are removing it. Double bond O minus OH. What is this? HPO4 minus 2 plus H plus. You have removed a proton. On removing proton, whatever the species is obtained, and that is called as what? Conjugate base. What's that called as? Conjugate base. So this is conjugate base of HPO4 minus 2 is the conjugate base of H2PO4 minus. So what did you understand up to now? When some substance is given and if you want to know the conjugate base of that substance, just remove one proton. When can you remove that proton? If proton is present for that substance and that proton is able to be ionizable. That proton is ionizable proton, then only you can remove it. After removing that proton, whatever the species is obtained, and that is called as what? Conjugate base of that particular substance. Then how you get the conjugate acid? Simply now what did you do? Removing proton gives you conjugate base. Adding a proton gives you conjugate acid. For a substance, if a proton can be added to that substance, and if that proton is added to that substance, then automatically after adding proton, whatever is obtained, and that is called as what? Conjugate acid of that substance. See, the addition of proton to a Bronsted-Lowry base gives you conjugate acid. Why we are calling it as conjugate Bronsted-Lowry base? Because proton is added. The base is able to accept the proton, right? So when proton is added to base, then we get its conjugate acid. So now let us take here NH3 is there. So for NH3 I am adding one proton. What did you get? NH4 plus. Then what is this called as conjugate acid? Because you have added a proton. Now this is called as conjugate base. And NH3 and NH4 plus are called as what? They are differing by a proton. Those two are called as what? Conjugate acid base pair. Understood? So for a base, if you add H plus, it becomes acid. From the acid, if you remove H plus, it becomes conjugate base. Simple thing. Removal of H plus forms conjugate base. Addition of H plus gives you conjugate acid. That's it. Okay. Now what you are doing? PO4 3 minus. That means you can write it in this way. Okay. What you are doing? You are adding one proton. When you add proton, what happens? It becomes OH. This remains as O minus, O minus. What is this called as? This is called as PO4 3 minus. What is this called as? HPO4 2 minus. Okay. So now have you added one proton. Now what is this called as? This is conjugate acid. What is that? Conjugate acid. Then what will be this? It has taken a proton. So what is this conjugate base? What do they differ? They differ by a proton. So these two are called as conjugate acid base pair. Conjugate acid base pair. Right? So what is the conjugate acid of OH minus? OH minus when added with proton gives you H2. So what is this conjugate acid? What is this conjugate base? Conjugate acid base pair. In the same way, H2O is added with proton to give you H3O plus. What is this conjugate acid? What is this conjugate base? As they are differing by a proton, these two are called as H2O and H3O plus are called as conjugate acid base pairs. Understood? Okay. Next, coming to the conjugate base of a strong acid is weak. Okay. The conjugate base of a strong acid. See, let us take here given example. What is that example given? HCl. See, HCl is having more tendency to lose H plus. If it is having more tendency to donate proton, then it is called as strong acid. Let us see here. It converts into Cl minus plus H plus. See, what is this acid? Then what will be this? This will be conjugate base, because they are differing by a proton. Okay, HCl is having more tendency to lose H plus. Why? It is electronegative element. Chlorine is electronegative element. More electronegative element, belongs to halogen group. After gaining this electron, it is getting highly stability. It is getting high stability. It is highly stable. So when it is highly stable, will it like to take again proton? No. If it is having tendency, see, if Cl minus is having more tendency to take proton, we say that it is strong base. Strong base means the one which is having more tendency to accept proton. Having more tendency to accept a proton. So Cl minus, as it is highly stable, it is not having tendency to accept proton. It don't want to take the proton because it is already stable. That is the reason why HCl readily lost H plus. Why HCl lost readily H plus? Because after losing H plus, it becomes Cl minus. The Cl minus is highly stable. That is the reason why HCl readily loses H plus. As HCl is readily losing H plus, we say that it is a strong acid. Strong acid. Now, what about this conjugate base? Whether it is strong or weak? It is not having tendency to take the proton. So it will be what? It will be automatically weak. Weak. Okay. So always you have to remember that if acid is strong, then its conjugate base will be weak. If base is strong, conjugate acid will be weak. So among conjugate acid base pairs, you have to remember that if one is strong, the other one will be weak. See here, CH3COOH is a weak acid, so acetate ion is strong base. The conjugate base of weak acid is strong. Now let us see CH3COOH dissociates to form what? CH3COO minus H plus. This forward and backward arrow represents that it is weak. It is weak. It is weak represents that it is not having much tendency to release proton. Okay. So as it is not having tendency to release proton, we say that it is weak acid. What is this? Weak acid. To this acid, what is this? Conjugate base, right? These two are acid base pair. What acid base pair? Conjugate acid base pair. Why? Because they are differing by a proton. As they are differing by a proton, they are conjugate acid base pairs. Now you see, it is having less tendency to release H plus. If it is having less tendency, what happens to this conjugate base? It will have more tendency to take proton and convert into acid. If one is having less tendency to release proton, its conjugate base will have more tendency to take the proton. When it has more tendency to take the proton, automatically we say that it is strong. What is that? Strong. So if already I mentioned you in the conjugate acid base pair, if one is weak, the other will be strong. Other will be strong. This point you need to remember. Simply remember that. Here this is not acetic acid is not having tendency to release proton. So acetate ion will have more tendency to gain proton. Okay. Next, let us the conjugate acid of a strong base is weak. See, OH minus takes proton to convert into H2O. So now it is having more tendency to take proton because it is negatively charged. If you take H plus, it becomes neutral, it becomes stable. So what is this strong base? Because it is accepting a proton. And what will be this? This is conjugate acid of OH minus. As it is strong, having more tendency to take proton, it will have less tendency to release proton. Water will have less tendency to release proton. As it is unable to release proton or having less tendency to release proton, we say that it is weak. Okay, it is weak. Okay, so in the same way, the conjugate acid of a weak base is strong. So C2H5OH, weak base. Okay, it is not having tendency to take this C2H5OH2 plus. Why? See here it is neutral. It is here charged. Neutral more stable than charged in this case. So what we say, it is weak base. So automatically what is this? It is conjugate acid of C2H5OH. If one is weak, other will be water. Automatically it will be strong. Okay. It will be strong. So what is the cumulative, or what is the summary of the conjugate acid base pair? Among the conjugate acid base pair, if one is strong, other will be weak. That's it, simple thing. Right? So here you are given some substances and you are asked to find the conjugate base and conjugate acid for this. HCl. Conjugate base means normally we have studied that if you are asked conjugate base, then remove proton. If you remove proton from HCl, what do you get? Cl minus. That is the conjugate base of HCl. Can you add H plus to HCl? Not possible. Is H2Cl plus possible? No. So there is no conjugate acid to HCl. Okay. H2SO4 conjugate base. Remove one H plus, then what do you get? HSO4 minus. For H2SO4, can you add H plus? Is H3SO4 plus possible? No, not possible. So there is no conjugate acid for H2SO4. HSO4 minus. For HSO4 minus, if you remove H plus, then what do you get? SO4 minus 2. So SO4 minus 2 is the conjugate base of HSO4 minus. Then what is the conjugate acid of HSO4 minus? Can you add H plus to this? Yes. If I add H plus, see, H plus plus HSO4 minus gives you what? H2SO4. So what is the conjugate acid of HSO4 minus? What is this? H2SO4. Simply add H plus to that. When is that possible? If proton can be added, then only you can add. If it's not possible, you cannot add. See, for HCl, is it possible to add H plus? No. So possibility also you have to think about. Can you add H plus to H2SO4? It's not possible. Now let us take HSO4 minus. What is the conjugate base of SO4 minus 2? What is this? SO4 minus 2. What is the conjugate base of SO4 minus 2? Is there a proton here? No proton. When there is no proton, can you remove it? No. So there is no conjugate base for SO4 minus 2. Is there conjugate acid for this? Add one, see, SO4 minus 2 plus H plus. Charge you see. Here it is minus 2, here it is plus 1. So overall the charge is HSO4 minus. Plus 1 minus 2 gives you minus 1. Are you getting this? Plus 1 minus 2 gives you minus 1. So what is the conjugate acid of SO4 minus 2? HSO4 minus. Now, can you remove proton from H3PO4? Yes. If I remove proton, I get conjugate base. What do I get that? H2PO4 minus. I am removing proton. What did we study on removing a proton from the substance? It gives you conjugate base. On adding a proton, can you add proton to this? Is H4PO4 plus possible? Not possible. So there is no conjugate acid for H3PO4. H3PO4 cannot act as a conjugate base. It cannot act as conjugate base because it cannot take proton. It cannot accept proton. Possibility is not there. After accepting proton, There is no such compound formed. There is no such compound formed. Now let us take H2PO4 minus. On adding proton, what do you get? Removing proton, HPO4 minus 2. When you remove proton from H2PO4 minus, you get HPO4 minus 2. Possible? Yes, possible. The conjugate base of H2PO4 minus is HPO4 minus 2. What is the conjugate acid of this? Let us add on proton H plus H2PO4 minus gives you what you write H3PO4. So H3PO4 is the conjugate acid of H2PO4 minus. So if a compound from compound, if H plus is, if it can lose proton and if it can accept a proton, then it can act as both acid as well as base, because it is able to donate proton, so it is acid. It is able to accept a proton, so it is base. So it can act as both acid as well as base. Okay. Now let us see this HPO4 minus 2. Yes, if you remove one proton, it can convert into PO4 minus 3. If you take proton, it can convert into H2PO4 minus 1. So it can also act as both acid as well as base. So here also it can act as both acid as well as base. Rounded one can act as both acid as well as base, you see. PO4 minus 3, there is no proton, so no conjugate base. Can you add proton? Yes, if I add proton to PO4 minus 3, it converts into HPO4 minus 2. Yes, it can act as it can act as the Bronsted-Lowry base because it can accept a proton. Can it act as acid? No, it cannot donate a proton. PO4 minus 3 does not have proton. How can it donate it? So NH3, can it lose a proton? Yes. So NH2 minus will be the conjugate base of NH3. What will be the conjugate acid? H plus NH3 gives you NH4 plus. Yes, we have conjugate acid to NH3. So when one substance is given, if H plus is added to that, the formed species called as conjugate acid to that. After removal of proton, whatever the species is obtained, and that is called as what? Conjugate base. Okay. Now let us. Is there possibility of removing one more hydrogen from this? NH minus 2. So possibility is there. Plus H plus. So this will be the conjugate base of NH2 minus. Then what will be the conjugate acid for this? NH2 minus plus H plus gives you what? NH3. So NH3 is the conjugate acid of NH2 minus. N3H. So what is N3H called as? N3H is called as hydrazoic acid. Hydrazoic acid. As it is having one hydrogen, it can be removed as proton. So what do you get? N3 minus azide ion. It is called as what? Azide ion. N3 minus is called as azide ion. Can you add H plus to this? No, it's not possible. So what is the conjugate base of acetic acid? CH3COO minus. Is there a conjugate acid possible to that? No, you cannot add H plus to acetic acid. In the same way, can you remove proton here? AR, yes, HS minus. Is there possibility to add hydrogen to this? No. HS minus. Is there a possibility to remove proton? Yes, it can convert into S minus 2 after removal of proton. So can you add hydrogen to this? Yes, proton. Proton, if it is added to HS minus, it converts into H2S. So H2S is the conjugate acid of HS minus. So HS minus can act as both acid as well as a base. So is there hydrogen? No. So no possibility of removal of proton. Is there possibility to add proton? Yes. H plus S minus 2 gives you HS minus HNO3. Yes. NO3 minus conjugate base. Is there possibility to add a proton to HNO3? No, not possible. As there is no proton here, no conjugate base for NO3 minus. Can you add H plus? Yes, H plus NO3 minus gives you HNO3. So HNO3 is the conjugate acid of NO3 minus. Can you remove H plus from Cl minus? Not possible. Can you add H plus? Yes. After adding H plus, it gets HCl. Can you remove hydrogen from HCl? Yes. If I remove hydrogen from HCl, it forms Cl minus. Can you add H plus to this? Not possible. Can you remove hydrogen from Cl minus? There is no proton, so not possible. Can you add H plus? Yes, I can add H plus. H plus plus Cl minus gives rise to HCl. Okay, so this rounded one, HS minus, and NH2 minus H3PO4 minus 2, for which both conjugate acid base pairs are present, then that can act as both the acid as well as a base. Now you understood. From the given substance, if you remove proton, you get conjugate base. If you add proton, you get conjugate acid. Okay. So an acid which shows greater tendency to donate protons is called as strong acid. So this HClO4 perchloric acid, what is this called as a perchloric acid. H2SO4, HNO3, they have more tendency to donate protons, so they are called as a strong acids. The acid which shows less tendency to donate protons is weak. Is acetic acid, hydrogen cyanide. These are having less tendency. That's the nature of those acids. You can also explain based on resonance, but resonance is not here. We don't discuss resonance. You know, strong acids, strong bases, weak acids, weak bases. H2SO4, HClO4, HNO3, H3PO4. What are these strong acids? Weak acids, acetic acid, hydrogen cyanide. They have less tendency to lose proton. Here coming to a base which shows greater tendency to accept protons is called as strong base. So what you are speaking here is the difference between strong acid, weak acid, strong base, weak base. Base means already we understood that ability to accept a proton. If it is having more ability to accept a proton, then that will be strong base. Like here CH3 COO minus. So this minus is on negative charge. It has to lose that negative charge. So when a proton comes, it readily accepts that proton and convert into CH3 COOH. So it became neutral. Now it is stable. So it readily accepts this H plus. So what is this? Acetate ion. Acetate ion is strong base. Okay. What is this? This is acid actually. Weak. What is this base? Automatically it is conjugate base. It will be strong. Before also we have discussed the conjugate base of a weak acid is strong. In the same way, here also you can see a base which shows less tendency to accept protons is weak base. Chlorine, stable, highly stable, shows less tendency to accept proton. Okay, so it will be automatically weak base. In the same way, NO3 minus is also stable due to resonance. So automatically it also weak base. It is also weak base, right? Let us see what is given here. The basicity of Bronsted acid is the number of H plus ions given by molecular ion. So what is the basicity of H3PO3? So let us draw the structure of H3PO3. So here P double bond O, OH, right? OH, H. There are 3 hydrogens. 1, 2. What about this third one? Okay. What about this third one? Right. See here, 2 hydrogens. Only hydrogens which are bonded to more electronegative atom, these two can only be ionizable. This is not ionizable, non-ionizable. That means it cannot be removed as H plus. It is directly bonded to central atom. In oxy acids, before also we have discussed that when if hydrogen is directly bonded to central atom, it is non-ionizable. Only these 2 hydrogens are ionizable. So these 2 are removed as H plus. So what is that basicity called as 2? Though it contains 3 hydrogens, only 2 can be removed or ionizable. Next, H3PO4, let us take, there are 3 hydrogens. All these 3 hydrogens can be ionizable hydrogens. All the 3 are ionizable. These 3 are ionizable because 3 are attached to more electronegative atom oxygen. In oxy acids, if hydrogen is bonded to oxygen, that hydrogens can be ionizable. But if hydrogens are bonded to central metal atom or central atom, then that hydrogen is non-ionizable. The number of ionizable H plus ionizable hydrogens is called as what? Basicity. Okay. Before also I discussed this. There will be protons. That means there will be hydrogens in that acid, but all the hydrogens present in the acid may or may not be ionizable. So that is, here is an example, best example. There are 3 hydrogens, but only 2 are ionizable, 1 is non-ionizable, right? So acidity of a base, Bronsted base, is the number of OH minus given by a molecule. In most cases, you find that bases, how many OH are present, those all will be ionizable. So the number of OH here, the number of OH is called as acidity of a base. What is meant by acidity of a base? For base, we are calculating acidity. How many OH minus it is able to produce or it is able to ionize? How many OH minus? that number of OH minus given by a molecular ion is called as what? Acidity of a base. So for the base we calculate acidity, and for acid we write basicity. Okay. So Bronsted acid functions as acid only in the presence of proton acceptor. For example, let us take water. So water, if you add acid, then HCl plus H2O gives rise to what you get, right? Considering this as a reversible reaction, what you get, H3O plus Cl minus. Now H2O is able to take this proton from Cl, HCl, then only it can act as acid. Okay, but if you add to benzene C6H6, C6H6 cannot take proton. As C6H6 benzene, what is C6H6? Benzene. This benzene cannot take proton from HCl. Now HCl cannot act as acid. See, HCl functions as acid in water, but not in benzene. Why? Because benzene cannot accept proton. So Bronsted acid can act as acid only in the presence of base, that is proton acceptor. Because if there is proton acceptor, then only it can accept proton from acid. So that acid behaves as acid. Are you getting this? So Bronsted base function as base only in the presence of proton donor. If there is no proton donor, how can a substance take proton? When a substance takes proton, then only we say that it is acting as a base. If other substance is not giving proton, how can this substance take the proton and act as base? It's not possible. Okay, so Bronsted base function as base only in the case of or only in the presence of proton donor. Bronsted acid function as acid only in the presence of a proton acceptor. Okay, and the compound which acts as proton donor as well as proton acceptor is called as amphoteric or amphiprotic substance, like H2O. See, H2O can lose proton and convert into OH minus, so it becomes conjugate base. It can take one proton and convert into H3O plus, this is conjugate acid. So for H2O the conjugate acid is H3O plus, and for H2O the conjugate base is OH minus. So H2O can release proton, accept proton. So now H2O can be amphoteric. Amphoteric means which can act as both acid as well as base, depending upon the situation. It can release proton as well as it can accept a proton. In the same way, NH3. So NH3, if it releases a proton, then it can become NH2 minus. If it accepts proton, it can become NH4 plus. So the conjugate acid of NH3 is NH4 plus. The conjugate base of NH3 is NH2 minus. The one which can behave both as acid as well as base is called as amphoteric or amphiprotic substance. Right? So what are the drawbacks of this Bronsted-Lowry theory? Bronsted-Lowry theory explains the behavior of acids and bases both in aqueous and non-aqueous solutions. That is one of the benefit. Advantage. What are the drawbacks? Let us see what are drawbacks. Proton donation or acceptance happens only in the presence of other substance. One substance can donate proton only if other substance take this proton, And if substance can accept proton only if another substance donate proton. Are you getting this? If another substance is not there, then this substance cannot act as acid. So a substance cannot act as acid or base if another substance is absent. Acid cannot act as acid if base is not present. Base cannot act as base if acid is not present. That is the situation here. So that is one of the drawback. Another drawback is Bronsted-Lowry theory could not explain the acidic nature of some electron deficient compounds like AlCl3 and BCl3. He could not explain. So here the acidic nature of these compounds is explained by Lewis theory. We will learn that. Okay. Coming to types of solvents. Different types of solvents. So on the basis of proton interaction, solvents are of 4 types. One is protophilic solvents. Solvents which have greater tendency to accept protons. Solvent means we know the best solvent as water, universal solvent. Here solvents are classified based on their interaction with proton. If a solvent can accept proton readily, those are called as what? Protophilic. Okay. Philic means attracting, loving. Proton attracting solvents. Proto means here proton meaning. Philic means attraction, attracting, proton attracting species. So the species or the solvent, here what we are speaking, solvent, the solvent can attract proton, take proton, accept proton. Such solvents are called as protophilic solvents. Protogenic, genic means producing, solvents which have tendency to produce protons, to release protons. So what are the examples? Water, liquid hydrogen chloride, glacial acetic acid, these are all able to release protons. Here protophilic, water, alcohol, okay, liquid ammonia, these are having a more tendency to accept protons. So let us take protophilic one example, H2O plus H plus, they convert into H3O plus, NH3 plus H plus gives you NH4 plus in that way. Here water releases H plus to convert into OH minus plus H plus. In the same way, HCl gives you H plus plus Cl minus. So these protogenic means produce protons, protophilic means accept protons. Amphiprotic or amphoteric. Amphoteric means solvent which act as both protophilic and protogenic, which can donate, which has tendency to lose proton as well as to accept proton. Before we have seen water, here also we can see. So water can accept proton, convert into H3O plus. In the same way, water can lose proton and convert into OH minus. Okay. In the same way, ammonia can lose and accept a proton. Ethyl alcohol can lose and accept a proton in that way. Next one is amphiprotic. Amphiprotic already we have seen. This is aprotic. Aprotic solvent means the solvent which neither donate proton nor accept proton. It don't have tendency to donate proton. It don't have tendency to accept proton. Such solvents are called as what? Aprotic solvents. Like water, benzene, C6H6, carbon tetrachloride, CCl4, CS2, carbon disulfide. These do not have tendency to accept protons. These do not have tendency to donate protons. Such solvents are called as what? Aprotic solvents. Okay. So that is about what Bronsted-Lowry theory of acids and bases. In the next lecture, we will discuss about Lewis theory of acids and bases. Thank you for watching.